All right, welcome to LuTube and this lesson on similar triangles. And we're going to show you or explain to you what similar triangles are and then show you how we can use this information to solve similar triangles. So let's start right off, jump right in and talk about what are two similar triangles. And two similar triangles are two triangles with equal angles, all equal angles. So let's write that down. Let's go. Two triangles. Okay, I'm going to use a symbol there. That's a triangles with equal, all equal. Some reason my pen doesn't want to write there. Equal angles. So all three angles are equal. In fact, once you have two angles that are equal, you're okay. And this is just my symbol for the word triangle, right? So triangles there with equal angles. And once we have that, basically the shape of the triangles is exactly the same. And so we can use this information to solve solve triangles, okay? So we're going to use this to find the missing side of one of the two similar triangles. And then we can it's helpful. It's just a way of working in geometry, and it's going to lead us into some trigonometry, which is what our next unit is going to be on, okay? So this is sort of a little preparation unit for trigonometry. So here we have two similar triangles. Now, typically, the sign for similar is not an equal sign, but it's like a wavy sign like this, and it tells us they are similar. It means that they have some properties that are very much the same. And in this particular case, what we can look at is say this angle here is equal to this angle here. This angle here would be equal to this angle here. And this angle, we'll say down here, we'll call it, I don't know, P is equal to P over here. So I used X, O, and P for my angles just for fun. Now, in order to solve, there's a series of steps that helps make it very easy for you. And it's very useful if you have some highlighters. So I'm going to use the highlighters I have, but I'll also show you ways you can do it if you don't have a highlighter. It's not like it's a big deal, but it's just useful. Kids, I find once I show the method using highlighters, students do much better. So I can turn my highlighter on. What I'm going to do is I'm going to show the corresponding similar sides in each triangle. So what I want to do is I want to say this side here in this triangle, which I'm going to highlight in yellow, will be corresponding similar side is over here. Okay. And then what I can do is change my color to a different color, whichever one you want. And I can say this side here is similar and corresponding to this side here. Now, I don't really need to mark the third side because it becomes obvious now that I've got two sides done. I don't need to kind of put more on, but if you have a third colored highlighter and you want to highlight it, that's great, do it. Now, if you don't have a highlighter, one of the things that students will do is they'll use like little tick marks, okay? So for example, they might put two tick marks on this one and two tick marks on this one to indicate that these two sides are similar and corresponding. Now, I'm not a big, huge fan of tick marks because that usually means that those two sides are equal in length, and they're clearly not equal in length. But when we're working with similar triangles, it's just a way to help us organize which sides are similar. And I give a mark to students for actually doing this. I find that since I've instituted this sort of policy where I say, show me the similar sides as part of your solution, students do much better. And what you can start to see here is that this 5 is this 5 here is similar and connects to this 15, and then the 3 connects to the X, and these two sides that we don't really know, they tie to each other as well. So just by drawing lines to each other, that helps as well. I'll find that it's a little messier, and so I tend not to encourage it with my students because it just makes the solution quite messy. Now, in order to solve this, I can do it quite easily. I'll do it here over to the side, providing everything goes well for me. I'm just going to sort of try to reduce my screen size just a tiny bit here. Just bear with me. There we go. And what we do is we always start by saying what we know, the two givens. So write the expression with the two givens. And we don't say they're equal because we know that 5 is not equal to 15. But what we do is we say 5. Oh, wow, it's going to give me a hard time here. I might have to write down here. 5, no, sorry, I'm on the eraser. That would help. 5 goes to 15. And so we're taking the values from this triangle and we're saying they go to this triangle. And then what we're going to do is we're going to say that's what we know, what's given in both cases, okay? And then what we're going to do is we're going to take 3 and we're going to go to x. It's really important that it be 3 goes to x and not x goes to 3. So these two and these two must be from the same triangles, okay? So the 5 and 3 are from this triangle, and the 15 and x are from this triangle. It's very important. Now, we don't have an equation here. We just have a series of lines that are saying 5 goes to 15, 3 goes to x. And we can use this to create an equation by doing a cross multiplication. So what we do is we take the x and multiply it by the 5, and we say that will equal the 3 times the 15. So we do this thing called cross multiplication. And so this is 5x will then equal 3 times 15. And that allows us now to solve for our x. We have an equation that we can solve for. So we can say 5x equals 45. And now we can divide both sides by 5. Dividing both sides by 5 is x equals 9. And we have our answer. The only thing we should do still is include our units. So I should write centimeters in here, and away I go. Okay? And that provides me my solution when I'm solving similar triangles. In fact, it could be similar shapes, and we'll maybe do a quick example or explanation of what I mean by that. So there's a series of steps that we can include. Oh, for some reason my writing wants to come down with me. So, well, that's okay because that helps me with my steps here. So number 1, I can say here, number 1, I can say that the first step was to highlight my similar or corresponding similar sides. So I'm going to say highlight the similar corresponding sides. And I would say that is maybe the most difficult step for students. And most students who get that, they have no problem moving along in solving this particular types of questions. But if you can get that, you're in good shape. The second step is to state the equal or state the similar given sides, sorry, not equal, the similar given sides. And we use an arrow for that, right? We use an arrow, we don't write it as an equal sign. Sorry, I'm going to erase that line underneath here if I can get my eraser to work. For some reason, it doesn't want to again. What the computer doesn't like is when I'm touching the screen with my hand in other places. Well, it just does not want to erase. So bear with me here, folks. See if I can get this to erase here. Nope. It is not going to do it for me. So just presume that's an arrow there. For some reason, it will not erase for me. So we'll go back here. I'm going to go back to writing. Step 3 is state the similar given sides with the unknown, and then that's state the similar sides with the unknown, which is our variable that we're looking for. So our x, unknown would be your x or whatever letter they're using. Then we use cross multiplication to create an equation. Cross multiplication, right, to make an equation. I'm missing the word "and" equation. And then finally, we can solve that equation. So there's a whole series of solve the equation, right? There's a whole series of steps that are going on here, but that is essentially the steps we went through. So here was step 1, if I write it up here. Here was step 2. Here was step 3, making the equation. Here was step 4. And then, of course, that was the cross multiplication with step 4. 3 was in here, and then this was 4. And then here's 5, solving and getting my answer. And then usually putting a box around it, somehow highlighting it. I don't generally require a therefore statement here. I just require you to do this. So let's do one more example and go through it. And this time, oh boy, what the heck is going on with this? It's not going to let me. Wow. That's crazy. Well, I'm going to try closing this and opening it up again and seeing if I can, don't save, and see if I can do this and it'll let me not move that text. That text should not move with me. So just bear with me here for a second as I reopen the file again. See if it causes the data to stay put. It looks like it's going to now. Good. There we go. All right, so here's another example. You can go back in the video if you want to see that previous part anytime. So in this particular case, we've rotated the triangles a little bit, make it a little trickier to identify the sides that are, in fact, similar and corresponding. And so what I find here is this will cause a little bit more challenge for students, okay? So I'm going to turn my highlighter on, and I'm going to recognize I'm looking for two sides that are of the same sort of character in here. And so like I'll often look for the two shortest sides or the two longest sides, two sides that match up, and that's what I'll look for. In this particular case, I see that the 13 is the shortest side here and the 39 is here. So these two are the corresponding sides, okay? And so I will go like this and highlight those two. In this particular case, I got my purple highlighter on, okay? And then what I'm going to do is look for the other two, another pair of sides that are corresponding, okay? So I'll turn to a different highlighter. In this case, I'm going to say that this here is a corresponding side, as is this here, 24, okay? So these two sides are corresponding, and that would leave me with the other sides, B and 96. These two sides are corresponding. If you have another marker, a different color, and you want to, you can gladly highlight those two sides, and then you have all three sides highlighted together. If you didn't, it's sort of obvious that those two sides are corresponding, okay? So let's solve for the A variable the first time. And what I'm going to do is always start with writing the two sides that we have a value for. So we have given information for. And so in this particular case, if I look at A, which is in yellow, and its partner, it's 24. I don't have A, so I don't want to start there. I want to start with the two that I have. In this case, I have 13 and I have 39. So I'm going to go 13 goes arrow to 39. I'm not saying it's equal. I'm just saying it goes to 39. Okay. And then I can say, because it was 13 that I started with, I have to start with 24. I have to write it underneath the 13 because they belong to the same triangle. So 24 goes, and it goes to A. So it goes to A. And now I can use my cross multiplication to solve this. So I take my 13A, 13 times A will be 24 times 39. And that's not something that, I just happen to know off the top of my head, 24 times 39, but now I can put this in as an equal sign. Sorry, I missed that. That there should be an equal sign. So let me rewrite that. Once I cross multiply, it allows me to get the equal sign. So remember, A goes to times here, and 24 goes to times 39, okay? And we generally put the things on the top row. It wouldn't be wrong to write the 24 times 39 on this side and the A equals 13 here, but we just generally do it in that fashion, okay? So now what I'm going to do is solve this. And so I need to know what 24 times 39 is. Well, I might need to use my calculator. And so I search my calculator on my computer in this particular case. And there it is. It comes up right away. And I say, was it 24 times 39? And that equals 936. So I'll minimize my thing and calculator. 936. So 13a equals 936. And in order to find a, I'm going to divide both sides by 13. So a will equal, and what is that? I need to, I can write a 13 a little better there. And I'll grab my calculator again, and it's 936, and now it's already in there, so I just have to say divided by 13, and this comes out pretty handy to be 72. And I can put my units on. In this particular case, it's centimeters, so I write centimeters over here where A is, and I look at the triangle with A is, and those are the units that I'm going to use. And that basically I could write this in here, 72 centimeters. And then think about it for a minute. Does it make sense? 72 centimeters, does that actually make sense given the context of that triangle? And it sure does. It makes sense. Sometimes students will make mistakes, and they're obvious mistakes, like they'll get, 4,052 here. Well, clearly 4,052 is not right. Or even if they had, for example, stop here and wrote 936. 936 doesn't make sense. How could 936 be there? There's no way in the world that 39 and 96 could be here, and this is 936, and then you might want to recheck your answer, okay? Now let's do the one where we solve for B. Well, it starts off exactly the same way because the only two that we are given is 13 and 39. And so I start with writing 13 goes to 39. And then I'm going to do the one with B in it. And that's B is under the 13 because it belongs there with it in that triangle. B goes to 96. Okay, and now what we're going to do is do our cross multiplication. So the 96 is going to multiply up there, and the B is going to multiply there. So it becomes 13 times 96 equals 39 times B, which we know is 39B. Okay, now I need to do my math again. I need my calculator. So I grab my calculator for a second. It's not that hard. Clear this one off, and I go 13 times 96, and that equals 1,248. So that's 1248 equals 39B. Now, flip these. I usually flip it at this point because sometimes I'll flip it in the last step already, but I'll write it as 39B equals, 39B equals 1248, and I sometimes would have done that flip right there, save myself a little bit of work, right? That's a B, not a 6. And now I'm going to divide both sides by 39, and I should have my answer here. I just rolled my screen up a little bit, divide both sides by 39. Let's go to my calculator again because I don't know that in my head too easily, so I divide by 39, and I get the answer of 32. So B equals 32, okay? And now I put my units on again. I look for the units in that triangle. They're centimeters, so it'll be centimeters, and I put a box around it. Sometimes students will write 32 centimeters here, and I think that's a good idea because it helps you give a sober look at this. Does 32 sort of make sense? Yeah, 13 and 24. This looks like the longest side, so 32, and it makes perfect sense. Okay. Now, some of the examples you might see in your worksheets might include shapes that are rectangles or whatever. So you could have like, a shape like this, and then over here it's a bigger version of the shape, but it's the same thing. You're going to equate this one to this one, these two to these two, this one to this side, similar sides, and then 4 ticks on this one, and you can use the same strategies to solve them, even though they're not triangles. Most of the questions are triangles, but you will see some that are not triangles. So that's how it works. That's working with similar triangles. Go give it some practice. Take a look at it, and hope you enjoyed this LuTube lesson, and we'll see you in class another day.